Everybody, Nicholas JMV here. Today we're going to do how to find the length of a curve, and this is part of our applications of integration. Okay, so let's go ahead and look at the definition. So to find the length of a curve, okay, here's what we need to know. The function f of x needs to be continuous and differentiable over that entire interval, and the length of the curve is then found by looking at the length is equal to the integral from a to b of the square root of 1 plus dy dx squared, and then you're taking the integral with respect to x. So here's the formula that we're going to use. Okay, there's also a formula for parametric equations, but let's look at when we have the length of a specific curve. So there's two ways that they're going to ask you. Number one, they're going to ask you to find the length, and usually AP will give you an example that you can calculate the integral because it can get messy. The other thing they can do and ask you is just to set up the integral, and we'll show both cases here. So let's look at this example. So let's find the length of the curve. Y equals x to the 3/2 from 0 to 4. Okay, so the first thing we need to find is dy dx. Oops. So we need dy dx. Okay, and we know that y equals x to the 3/2. Okay, so taking the derivative now, not the integral, dy dx equals 3/2 x to the 1/2. Okay, so we have that dy dx. And so now we can apply the rule. We're going from 0 to 4. Okay, so let's look at the integral. So from 0 to 4, that length is going to be equal to the square root of 1 plus dy dx, which is 3/2 x to the 1/2, all that squared dx. Okay, so let's go ahead and simplify the integrand here. So we go from 0 to 4, and we're going to have the square root of 1 plus 9/4 x dx. Okay, so this is when we got to get a little creative. We have to integrate this and evaluate, but we're going to use U-Substitution. So I'm going to go over here and let u equal 1 plus 9/4 x. That means du equals 9/4 dx. I don't have 9/4 dx, I just have dx. Solving for dx, I get dx equals 4/9 du. So multiplying each side by the reciprocal. Okay, so let's go ahead. So the 4/9, we're going to have 0 to 4 of u to the 1/2 du, and that's times 4/9. Okay, so let's bring the 4/9 out front. We're integrating from 0 to 4 of u to the 1/2 du. Okay, so what that becomes now is 8/27. 8 over 27 times u to the 3/2, or 1 plus 9/4 x to the 3/2. Okay, when I integrate this, add, it's just the power rule, simple power rule. Okay, so here's my equation. I got to evaluate from 0 to 4. So when I plug 4 in, okay, I get 8 over 27 times basically 10 to the 3/2 minus 1. Okay, when I go ahead and plug 4 in and I plug 0 in. So this is our final answer, f of b minus f of a. So that's how you're going to do that first example. That's how the AP will ask you. The second way they ask you is if they tell you to set up but do not evaluate. So here's our second example here. Okay, and we're going to look at set up but don't evaluate the integral. We're going to find the length of the curve. X equals sine of y from 0 to pi over 2, and let's set that up. We're going to find the length, but they just want us to set up, don't evaluate. So that's another thing that the AP could ask you to do. So we know that y equals x sine of y. Or excuse me, x equals, I apologize. So we go ahead and we take dx dy. So even though this equation is solved for y, we're going to take dx dy, and that's going to equal cosine of y. Okay, so once we take that, we find that derivative, we go ahead and plug it into our equation. So we're going to have from 0 to pi over 2. Okay, and we're going to take the square root of 1 plus the dx dy squared. So it's just going to be cosine squared of y dy. And that is our integral. They wanted us to set it up. They didn't want us to evaluate it. So if you guys have any questions or comments of how to use this formula for the length of a curve, you can go ahead and type them below. We'll see you next time.